In this video, we are going to see about the step-down chopper, which is also called as buck converter. A buck converter or step-down converter is a DC to DC power converter. In this, uh, we are converting the DC voltage into DC. The purpose is the input is fixed DC and the output is variable DC. Variable DC here, uh, the output voltage is less than that of input voltage. That is, output voltage appear across the load is less than the input voltage, that is the supply voltage. Here we are using SMPS, switching mode power supply, typically containing at least two semiconductors, a diode and a transistor. The switching transistor may be, the switching devices may be a transistor or a thyristor or any one of the switching devices. It may be MOSFET, IGBT, SCR, transistor, anything we can use for the switching devices. And the circuits which has the capacitor and the reverse bias diode and the charging capacitor, inductor and the load. Here there is two modes of operation. There is switch in position 1 and switch in position 2. There is switch in turned on condition and switch is in turned off condition. Here first we will see the mode 1 operation. When the switch is turned on, the supply from the input goes from positive switch and the inductor positive negative. So the inductor will get charged during this period, and then capacitor also will get charged during this period, and the output voltage appear across the load will be less than the input voltage, because the the input voltage supplied from the battery source will get uh, charged in the inductor and capacitor. So the voltage appear across the load will be reduced due to this charging. And then this is the operation mode 1, and the switch in the position 2, that is mode 2 operation, where the switch is turned off. When the switch is turned off, the supply is cut off, that is input supply is cut off from the for the circuit. Uh, when we note down the circuit 1, that the diode, reverse bias diode is uh, cut off, because the input positive supply goes to the cathode of the diode, so the diode is reverse biased, so the diode will not operate in the condition when the switch is turned on. When the switch is turned off, the inductor discharges the energy by reversing the sign. So the negative side will goes to cathode, the diode will be turned on, the energy will keep on circulating, that is discharging energy from the capacitor and the discharging from the energy from the inductor will goes to the load, which will be less than that of input voltage. The discharging values, the discharging voltages will move to the load. So some voltage will appear across the load that will goes to a closed path through the diode. So the we are getting the output voltage continuously and output current continuously because of this inductor and capacitor. Look into the waveform, that the switching state, voltage and current. When the switch is turned on, T on position, the voltage will be in positive side. When the switch is turned off, the voltage will move on to the negative side, because the negative voltage appear across the load. And look into the current will get increases, that is it moves up to the maximum value from the minimum value. When it reaches the maximum value, the switch will get turns off and the current keep on decreasing to up to the position on T off. When it reaches the minimum position, that is IM, again it get turns on and it keep on going. This current is inductor current, that is charging and discharging, again discharging and discharging. This shows the equation of and the waveforms of step down chopper. Already we know, we see that T is equal to T on plus T off, this total time for the voltages. So VA is equal to 1 by T integral of 0 to T on V in into dt. So VA is equal to 1 by T 0 to T V in, that is capital letter Vin, that is the voltage, maximum voltage appear across the diode. When we integrating this T on by T into Vn, which is equal to Fs into T on into Vs. 1 by T is taken as Fs. So Va is equal to D into Vs. D is nothing but duty ratio. D is equal to T on by T. That is T on divided by T on plus T off. This is the output voltage equation for the step down chopper. Then the average value of the load current. Ia is equal to V by R, sorry, Va by R, which is equal to K into Vs. That is D into Vs. It is taken as K by R. So K is equal to T1 by T, again the duty cycle. So the output value of the load current is Ia is equal to Va by R. Thank you.